Hi everyone, this is Babaiah, Assistant Professor of EC Department, MLR IT, Hyderabad. Today I am going to explain about the transient or time response of underdamped second order system for unit step input. In previous lesson, we solved or we derived the time response of undamped second order system for unit step input. Here just observe underdamped second order system response for unit step input as well as the graph. Now let's move on to this today's session overview. Is just observe here the expression or expression of time response of underdamped second order system for unit step input. Now we are going to see this one again, and also one more point is just observe the output or response of undamped second order system graph. Here now these 2 points now we are going to see in this lesson, in this lecture, right? See, just to move on to the first, I'm going to consider the one unity feedback negative feedback closed loop control system, that is the second order system. Now I am going to consider here. See here, in denominator part is s square, so s and s square, this is completely omega n square divided by s square plus 2 zeta omega n s. Right here maximum power of s is 2, so right here second order closed loop system, here unity feedback. The transfer function of this system is C of s divided by R of s is equals to, just I am going to consider this is G of s and this one is H of s, but a unity feedback system, so H of s equals to 1. Just simply here write G of s divided by 1 plus G of s into H of s. H of s equals to 1, right? So G of s just substitute in this equation, just we are going to get this equation. See, or else directly for all unity feedback systems we are going to calculate the transfer function. A simple method, just in G of s numerator part going to be adding with the denominator part, then this equation is nothing but the transfer function of the system when we are having the any unity feedback system. This is the simple trick. Just here, or else you are going to use the G of s divided by 1 plus G of s into H of s. In this substitute G of s, by this solving omega n square divided by s square plus 2 zeta omega n s plus omega n square. By solving is nothing but just here simply see, observe omega n square divided by s square plus 2 zeta omega n s divided by 1 plus omega n square divided by s square plus 2 zeta omega n s. Right here s square plus 2 zeta omega n s is just is common here from this omega n square divided by s square plus 2 zeta omega n s divided by s square plus 2 zeta omega n s plus omega n square divided by s square plus 2 zeta omega n s. This term get cancelled. Directly you are going to get omega n square, here omega n square divided by s square plus 2 zeta omega n s plus omega n square. This is the second order equation because of maximum power. See here, observe, by solving we are going to get this one. The maximum power of s is 2, so in denominator term, hence the about transfer function of the second order system is said to be the second order system, or else the maximum power of s is nothing but 2, so the given transfer function of the system is nothing but second order. So now we know this is the another name for the second order transfer function is the standard form of second order system. Now I am going to consider the standard form of closed loop transfer function. Standard form of closed loop transfer function of second order system is C of s divided by R of s is equals to omega n square divided by s square plus 2 zeta omega n s plus omega n square, right? So this is the standard form of closed loop transfer function. Now just in this session what we are going to learn for underdamped system. This is the very important for you. Underdamped system is very important. See here, 0 to 1, the zeta value between 0 to 1, the system is known as underdamped system. The roots of this denominator or characteristic equation is, the roots of this underdamped system is a complex conjugate. Roots are going to be complex conjugate. In previous session I solve also this one. Here see, once again here see, the roots of the denominator are, this is the roots by solving the characteristic equation. This is our characteristic equation, s square plus 2 zeta omega n s plus omega n square equating to 0 is nothing but characteristic equation. By using the quadratic equation, because of this is the order is 2, by using quadratic equation just we are going to this one, this equation. Previous lesson I derived this one also, right? Here see, the roots of the denominator are s equals to minus zeta omega n plus omega n under root zeta square minus 1. So denominators. So here observe the zeta value is in this condition, zeta value is greater than, right? But here what is for underdamped system, zeta value is less than 1. So is always, and means here zeta square also less than 1, zeta is less than, see here, since zeta is less than 1, so zeta square also less than 1, and so 1 minus zeta square is always positive. 1 minus zeta square is always positive because of zeta value is less than 1. So here always positive that value, right? Here see, observe, s equals to minus zeta omega n plus or minus omega n under root. Here just I am going to common the minus 1 here, this term. See here, observe, minus 1 just common 1. Minus 1 common means here 1 minus 1, here remain 1 minus zeta square under root. Here we know that j square equals to minus 1. J square equals to minus 1. So minus 1 equals to j square. Here j square just write square root get cancel. So j omega n. So j omega n minus zeta omega n plus or minus j omega n under root 1 minus zeta square. These are the roots. Roots are going to be complex conjugate. See here, real and imaginary. Minus zeta omega n plus j omega n under root 1 minus zeta square. Minus zeta omega n minus j omega n under root 1 minus zeta square. These two are the roots of underdamped system. The roots of underdamped system are the complex conjugate. And here see, now consider the observe the damped frequency oscillation omega d. We know that in previous session also. Omega d equals to omega n into under root 1 minus zeta square. Just substitute here. Omega d is nothing but damped frequency oscillation in radians per second. So omega d, in place of omega d, we are in place of omega d, I am going to write omega n under root 1 minus zeta square, or omega n under root 1 minus zeta square. Just substitute the omega d. See here, observe omega d simply, right? S equals to minus zeta omega n plus or minus j omega d, right? These are the roots. Now the response of the standard form. This is the standard form of closed loop transfer function. But that system response in S domain, response is nothing but C of S. Response is nothing but C of S. So C of S equals to R of S into that second order system standard form. Here we know that the input of this system is what, unit step, right? So unit step, for unit step input R of t is equals to 1. Apply the Laplace transform to this equation R of t equals to 1. By applying the Laplace transform, you are going to get this R of t, Laplace of R of t equals to 1 by s, sorry, R r of t is nothing but r of s, and here Laplace of 1 is equals to 1 by or 1 by s. Okay, here c of s is equals to r of s into omega n square divided by s square plus 2 zeta omega n s plus omega n square. Just here in place of r of s substitute 1 by s, here 1 by s. Okay, omega n c of s equals to omega n square divided by s into s square plus 2 zeta omega n s plus omega n square. See here, this is the equation. C of s equals to omega n square divided by, this is the s domain response. S domain response, this equation C of s equals to omega n square divided by s into s square plus 2 zeta omega n s plus omega n square. By partial fraction expansion, see here, observe, by using partial fraction of this equation, see s square plus 2 zeta, second order is there, omega n square by s, so a by s one term plus here s square plus 2 zeta omega n s plus omega n square quadratic. So here bs plus c divided by s square plus 2 zeta omega n s plus omega n square. Because of here quadratic equation, that is bs plus c divided by s square plus 2 zeta omega n s plus omega n square. See here, observe, by partial fraction a and b values now we are going to calculate. A is obtained, see here, a value is obtained, a value in denominator value is what, s, right? A value is what, denominator, so the c of s is multiplied by s and letting s equals to 0, substitute in this equation. Now you are going to get the a. For the a is obtained, see here, observe, a is obtained by multiplying c of s by s and letting s equals to 0, substitute. See here, a equals to s into c of s, letting s equals to 0. We know that c of s equals to omega n square divided by s into s square plus 2 zeta omega n s plus omega n square. Here s into this value, because of s is multiplied with c of s. So see here, observe, this s and this term s both are get cancelled, right? Next term here, omega n square divided by omega n square, just these two are going to be get cancelled, value a equals to 1, so a equals to 1, so a equals to 1. To solve for b and c, for the solving of b and c, just cross multiplying the equation, see here, and like powers, that is the this equation cross multiply for b and c, a value is equals to 1, so b, for b and c values, just cross multiply this equation and also compare or equating the like powers, s square term s square, s term s term, or and normal constant value constant, like that we are going to equating powers, s powers are going to be equating by solving this b and c and cross multiply that equation, and also like powers are equating. Here see, on cross multiplication of that equation, after substituting a equals to 1, we get, see here, this is what the previous equation, see here, observe, a by s plus bs plus c, a by s plus bs plus c divided by s square, s into s square plus 2 zeta omega ns plus omega n square. See here, s square plus 2 zeta omega ns plus omega n square, and a by s, and a by, sorry, this one is directly right, this term only. Okay, s square plus 2 zeta omega n for this term, right? See here, observe this term. Now here, just I am going to write this one here, a by s, that is equals to c of s. We know c of s equals to omega n square divided by s into s square plus 2 zeta omega n s plus omega n square, right? Here equating like powers, and a equals to 1, we know that, so c of s is equals to a equals to 1, so 1 by Yes, so 1, this is nothing but equating equals to s square plus 2 zeta omega ns plus omega n square, sorry, omega n square plus bs plus c into s divided by s into s square plus 2 zeta omega ns plus omega n square. Here c of s equals to, we know this term, s omega n square divided by s into s square plus 2 zeta omega square. So denominator term is here, denominator both are get cancelled, so omega n square. So directly from that, omega n square equals to s square plus 2 zeta omega ns plus omega n square plus bs square plus cs, bs square plus cs. Here c observe, see s term is here and s term is bs plus c, bs plus bs square plus cs. See here, observe this omega n square divided square equals to s square plus 2 zeta omega n s plus omega n square plus bs plus c of s, c of bs plus c into s. By solving this, omega n square s square 2 zeta omega n square bs square plus cs. Equating the coefficients of s square, we get here, see, observe, here this s square term for the left side or left hand side, there is no s square, so s square term here also there, s square term here also there. So s square term for s square is common, 1 plus b equals to 0, right? Here s square term is not there, so that is equals to 0. S term also just observe here, s term, so equating this one, s square terms 1 plus b equals to 0, so s square terms is 1 plus b, so s square here there is no, so 1 plus b equals to 0, so b equals to minus 1, so b equals to minus 1. So from this, just b equals to minus 1. And again also same s terms, just observe here, s term is 1 here there, and s also one more is there, so s term here just as common, 2 zeta omega n plus c, it is equals to 0. Here s term is 0, 0, so here 2 zeta omega n plus c equals to 0, plus c equals to 0, c equals to what? Minus 2 zeta omega n, minus 2 zeta omega n, right? Here see, observe, from this we are going to get this one, c equals to minus 2 zeta omega n, right? 1 by s minus, here a equals to 1 and s plus 2 zeta omega n divided by s square plus 2 zeta. See here, minus 2 zeta omega n and minus 1, b value is minus 1 and c also minus 1, minus minus both here minus are there, just here substitute. A equals to 1, right? So 1, here minus 1 and minus 2 zeta n, right? See here, minus 2 zeta omega, so minus minus both common, so minus common, so minus means here 1 plus 2 zeta n divided by this term, right? Zeta n, this term. See here, observe, s plus 2 zeta omega n, 1 by s minus, here b equals to minus 1, minus 1, so s plus 2 zeta omega n, just here see, observe, see, observe, already here s is there, bs, so 1, so s term, so 1 s term is there, s plus 2 zeta omega n divided by s square plus 2 zeta omega n s plus omega n square, right? Omega n square, this is the c of s after apply the a and b value. See here, that equation is just here, observe this one, that equation is this, c of s equals to 1 by s minus s plus 2 zeta omega n divided by s square plus 2 zeta omega n s plus omega n square. Let us add and subtract the zeta square and omega n square. Or else first you are to going to separate these terms. S plus 2 zeta is there, so zeta omega n and zeta omega n also you can write this one. So for that, zeta square omega n square to the denominator of second term in the equation, this equation. See here, observe, zeta square omega n square to the denominator of second term, denominator of here second term in this equation. Now I am going to add and subtract zeta square and omega n square. See here, next line, zeta square and omega n square. See, 1 by s minus s plus 2 zeta omega n, s square plus 2 zeta omega n s plus omega n square. Just this one is add and subtract in the denominator part of the second term. First term this one, second term. In second term, denominator is zeta square omega n square, zeta square omega n square. See here, 1 by s minus s plus 2 zeta omega n is there, s square plus 2 zeta omega n s plus zeta square omega n square. See here, observe, a square plus b square, a plus b whole square, right here, a equals to 1 to ab, to ab. So here, like that, here see, observe, s square plus 2 zeta omega n s plus zeta square omega n square, simply place by this here, omega n square minus this term is there now, so omega n square minus zeta square omega n square, zeta square omega n square. Simply I am going to write like that here. For example, a plus b whole square, that is equals to what, a square plus b square plus 2ab, right? Here in the same way, here see, observe, s square plus 2 zeta omega n s plus zeta square omega n square, 2 a b, a is zeta omega n, oh sorry, b is zeta omega n, a equals to s. Here simply a equals to s, b equals to zeta omega n, simple like that. Here just that consider a plus b, so s plus b whole square, simply just write. See, observe from this equation, and 1 by s minus s plus 2 zeta omega n, s plus zeta omega n square, s plus zeta omega n square from this equation, plus here omega n square minus zeta omega n square. Just here observe, omega n is common, so omega n square is common, 1 minus zeta square, right? We know omega d equals to omega n under root 1 minus zeta square, that is nothing but what, damped frequency oscillation, right? Omega d equals to damped frequency oscillation, that is omega d equals to omega n into under root 1 minus zeta square, under root 1 minus zeta square. Just substitute in place of omega n square under root 1 minus zeta square. Here by this solving, what, omega d square equals to omega n square 1 minus zeta square, right? Here omega d square, so substitute here omega d square. In place of this, substitute omega d square, right? 1 by s minus s plus zeta omega n divided by s plus zeta omega n square plus omega d square minus, just see here, observe, here we have a 2 zeta omega n's are there, two parts, zeta omega n, zeta omega n. See here, zeta 2 zeta omega n, I am going to write this one, zeta omega n plus zeta omega n plus, so that is nothing but 2 zeta omega n. Just simple that way we are going to use here, s plus 2 zeta omega n, s plus zeta omega n divided by s plus zeta omega n whole square plus omega d square minus here zeta omega n. One more point, because of here minus of this term, right? Minus of this term, so minus of this term is minus two terms, so minus and minus, minus of this term and minus of this term, right? Now here see, minus this value 1 by s minus s plus zeta omega n by s plus zeta omega n square plus omega d square. Just substitute. Let see, observe, this is in the form of just observe here omega, or else here s plus a, s plus a divided by s square plus omega, or s plus a whole square plus omega square. See here, this is in the form of formula, this is like that. Okay na? Omega by s plus, sorry, this one, s plus a divided by s plus a whole square omega square, s plus a divided by s plus a whole square plus omega square. This is in the form. Now see here, this is in form of S domain correct equation for applying the inverse Laplace. When we are going to apply inverse Laplace, we are going to get the time domain equation, that is it is in the form of accurate. Here see, observe zeta omega divided by s plus zeta omega whole square plus omega d square. It is not a valid formula consider. So that's why we are going to convert this into the formula for the inverse Laplace form. For that I am going to add or else divide and multiply and divide. See here, multiply and divide by the omega d in the third term of this equation. Third term here, first term, second term and third term. Now just I am going to omega d is multiply and divide and multiply that one, omega d. See here, c of s equals to 1 by s first term, and second term is as it is, s plus zeta omega divided by s plus zeta omega square omega n whole square plus omega d square. It is correct formula is came. And here minus zeta of omega n, here omega d is multiply and divide, so multiply and divide zeta omega and multiply omega d, and divide is omega d, so omega zeta omega n divided by omega d is this one. See here, observe, this is for example I am going to write the omega, I am going to write omega. See here, observe, this is in the form of omega divided by s square plus omega square, s square plus omega square, right here, or here in place of s plus a whole square plus omega square also you should write, no problem, s plus a. So this is in the formula it came. Now see, omega d by s plus zeta omega whole square plus omega d whole square. The response in time domain is given by, just simply, now I am going to just consider here time domain. For the time domain, s domain into time domain, we are going to apply the inverse Laplace. Now apply the inverse Laplace transform for this equation, now this equation I am going to apply inverse Laplace transform, apply. See here, inverse of c of s is nothing but c of t, inverse Laplace of complete term 1 by s first term minus s plus zeta omega divided by s plus zeta omega whole square plus omega d square second term, and here see, one second, see, minus zeta omega divided by omega d, and omega d divided by s plus zeta omega n whole square plus omega d square. This is comes under the this formula, this term is comes under this formula, and this term is comes under the this one formula. Two formulas here, 1 by s is nothing but here 1 by s, this formula, just Laplace, inverse Laplace, just here these are the Laplace, inverse Laplace, just time domain here 1 by s is 1. Okay, good. S plus zeta omega divided by s plus zeta omega whole square plus omega d square. This is the same formula. Here is the, see here, s plus a equals to zeta omega n, right? Here s plus zeta omega, s plus a whole square plus omega d square. That is nothing but here s term, numerator and denominator s is there, so cos omega, cos omega t, and here in term, this term is again is Laplace is s plus zeta omega n is e power of minus at, et. Here is plus is there, so e power of minus et is cos omega t. So e power of minus zeta omega n. Here a equals to what? Zeta omega n. A equals to zeta omega n. So that's why e power of minus at minus zeta omega n t. A plus minus zeta omega n t cos omega dt. Here d is there, omega d. So omega dt minus zeta omega n by omega d and e power of, here see, omega d. Here s term is there, in denominator only s term. So e power of minus, here plus is there, so minus zeta omega n t sine, here only one s term is there in denominator, so that's why here sine omega dt equals to, this is the formula here, 1 minus e power of minus zeta. Here minus zeta omega n t is there, e power of minus zeta omega n t is there. Just common this term, just common this term from this equation. Common is 1 minus e power of minus zeta. This completely 1 is there, 1 is here, e power of minus zeta just common, 1 minus e power of minus zeta omega just common term, cos omega dt plus zeta omega n divided by omega d. We know that omega d equals to omega n into under root 1 minus zeta square. Just to substitute that one here, zeta omega n divided by omega n under root 1 minus zeta square sine omega dt. Right here, see, observe, this is the omega d equals to omega n into under root 1 minus zeta square. Right, see, 1 minus e power of minus zeta omega d, just to substitute this one, just cross multiply this equation here, 1 minus, here this one is the denominator part is there, this is the common here, so that's why here e power of minus zeta omega n t divided by under root 1 minus zeta square. Here see, observe, zeta omega n term is there, omega n term both are get cancelled, so cos omega dt plus zeta by under root 1 minus zeta square sine omega dt, just this term. See here, under root 1 minus zeta square, here just common, this one is multiplied, 1 under root 1 minus zeta square cos omega dt plus zeta sine omega dt. See here, observe, I am going to draw the right angle triangle, or else here see, observe, 1 minus e power of minus zeta omega n t, zeta value is there, sine omega dt into zeta plus cos omega dt into under root 1 minus zeta square. Now I am going to draw this, or constructing the right angle triangle with zeta and under root 1 minus zeta square. See here, observe, constructing right angle triangle with zeta and under root 1 minus zeta square. Simply just nothing but is what here, see, I am going to write here, the theta is there, so theta under root 1 minus zeta square, and here the value is 1, so zeta with respect to, see here, observe, adjacent and here hypotenuse and adjacent base, here see, observe, this is adjacent, zeta under root 1 minus zeta square, here theta, for example sine, or else cos sine square theta plus cos square theta is equals to 1, right? Sine square theta plus cos square theta equals to sine theta equals to what here, under root 1 minus zeta square divided by 1, here opposite side by hypotenuse, here sine theta, or cos theta is adjacent, adjacent is here zeta by 1 hypotenuse, so sine theta equals to under root 1 minus zeta square, cos theta equals to zeta, cos sine theta equals to under root 1 minus zeta square, sine theta, cos theta equals to zeta, tan theta equals to sine by cos, that is under root 1 minus zeta square divided by zeta, that's it. Right here, see, zeta square by this, zeta square plus under root 1 minus zeta square whole square, square root cancels, zeta square minus zeta square is equals to 0, so 1, so 1 equals to 1, right? So that's why this is the correct. So here in place of under root 1 minus zeta square, I am going to write the sine theta, sine theta, so sine theta, I am going to write this one, sine theta omega dt plus zeta equals to cos theta omega dt, 1 minus e power of minus zeta omega nt divided by under root 1 minus zeta square sine omega dt into zeta sine omega dt, zeta is nothing but here what, cos theta, plus cos omega dt into, this is nothing but sin theta, right? Sin theta. So that's why sin A cos B, sin A cos B plus cos A sin B, that is here formula. Just see, observe, sin A cos B plus cos A sin B equals to sin of A plus B. Here sin A cos B, A equals to omega dt, A equals to omega dt, sin of omega dt plus B equals to what? Theta. B equals to what? Theta here. Here theta is there, theta. So sin A cos B plus cos A sin B, that is, this is the formula. From this formula, sin omega dt, we are going to get sin of omega dt theta. See here, sin A cos B plus cos A sin B, sin of A plus B, A equals to omega dt, B equals to theta, where theta equals to what? Tan theta. We know that tan theta equals under root 1 minus theta square. So theta equals to what? Tan inverse of under root 1 minus theta square. This is the, so this is the time response of underdamped second order system minus zeta omega nt divided by under root 1 minus zeta square and sine of omega dt plus theta. This is the underdamped second order system response for unit step input. For unit step input, for step input, just multiply the step value to the unit step. Here just the response of underdamped closed loop second order system for unit step input is this one. For a step value, just A is multiplied with the unit step, you are going to get the step response, right, where theta equals to this value. This is the very important formula. By using this formula only, we are going to calculate the time domain specifications. The time domain specifications also very important from the previous class we are going to explain, or coming classes I am going to explain, right? Here unit step response is this one, step response. Just observe the graph for underdamped second order system for unit step input. Just observed and sketched this graph is just for unit step input. This is our output. Just see the response of the second order system for underdamped second order system for unit step input is response is oscillates before settling. This is oscillates before settling to the settling to the final value. Here settling value, before settling to the final value, it is going to be oscillates. Here the response oscillates before settling to the final value. The oscillations depending on the value of damping ratio. Based on the damping ratio only, the value is going to be oscillation or oscillating, and the before settling of the final value, the response of the underdamped second order system is oscillating, right? Here see, observe response of underdamped second order system for unit step input. This is the graph or output of second order underdamped system for unit step input. This is about the transient or time response of the second order underdamped closed loop system for unit step input, right? I think, or I hope you understood every point. This is the very important of underdamped second order equation. By using this equation only, we are going to calculate the time domain specification. So that's why this is a very important. You should remember this one also. And by using this response only, by using this response or by using this graph, we are going to determine the time domain specifications, right? So this is about the transient or time response of underdamped second order closed loop system for unit step input. Thank you all.